Okay, so my name is Tomaž, and today I'm going to talk about AI agents and knowledge graphs. So, unfortunately, I have a bit more slides, so I should go first because now maybe you get a little bit disappointed because Liane was so good. But first, we'll go through a little bit of slides, and then I'll have like a quick demo as well at the end. So, as mentioned, my name is Tomaž. I've been with Neo4j for like 8 years now, and I write a lot of blog posts. And for each blog post, I try to produce the code. So, because like if you just look at articles like white papers and you don't actually see the code, like as a developer, they're not like really useful. So I really try to produce the code. And as mentioned, the debug demo was also my code. But let's go straight into it, right? So what are LLM agents and like how are they useful, right? So like in a typical RAG pipeline, how I see it is basically everything is predetermined, right? A user asks a question, we go to our knowledge base, fetch some information, pass it to an LLM, LLM summarizes the answer, and we get our answer back. We give the answer back to the user. So there's like nothing agentic here, right? But I mean, the thing is like if you ask 5 people what are agents, you'll get like 10 different definitions, right? But how I see it basically is an agent is when LLM has the option to decide what to do, like how to fetch the data or how to construct the data and generate like the final answer, right? So in this example, we have like one predetermined step, and then the LLM can decide either it wants to go to step 2 or step 3, right? So it's very simple, but it has the option to make a decision. And basically, the most popular framework I've seen so far is basically the React agent. So basically, we want the LLM to be able to do reasoning, right? So decide what they want to do. And then we also want to give them the option to actually go and do the thing they want to do, right? So here kind of the reasoning and acting comes into play. And this has been like a very popular architecture. And I feel like that the tools is like the perfect implementation when you want to do agents, because you give the agent a couple of tools it can use for specific use cases, and then like you give the input to the agent or the LLM. The LLM decides, okay, can I answer the question directly, or do I want to go and use any of the tools? It can be like one tool, multiple tools, and then the final answer is created, right? So basically for me, an agent is like if you just give like an LLM 2-3 tools that it can use, for me it's already an agent, right? So some people I say you want to add memory to the LLM, stuff like that. So that's like the add-ons, but like as soon as an LLM can decide what it wants to do, for me that's an agent. And mostly what we see in practice is that you can have a couple of predefined steps that you know you want to execute every time, and then along the way the LLM can decide of some of the steps it wants to do, right? So this is like one example from LangGraph and from Llama Index. And then what does this have to do with knowledge graphs? So I'm lucky that Liane did a nice introduction to knowledge graphs, so you kind of know what we're talking about. But like for like 15, 20 years now, it was kind of known that knowledge graphs are really good at representing structured data, right? Because you can have entities such as, or like nodes, such as real-world entities, or like digital entities. And here, for example, we have Mona Lisa, which was painted by Da Vinci, and so on. But like now, in the context of LLMs, it's much more mainstream, or like the use cases have shifted a lot more to unstructured data, right? Because everybody wants to talk with their PDFs or documentation, And the nice thing about knowledge graphs is that it's very useful for the structured data, but you can also add unstructured data, as was also shown in the demo. So here I have like one example of in a legal domain where you can have like a contract, and then you can have some structured information about that contract, like who signed it, where are those companies from. But then you can also append the unstructured information to the contract as well. Like so in this example, it would be clauses. And knowledge graphs are mostly domain agnostic, so you can represent any type of data that you want. And here I have like a DevOps knowledge graph where you can have like teams, microservices, and in this case, like your Asana tasks or like Jira tasks that are linked to the microservices, so the team could be your unstructured data, right? And the nice thing for me is that you can have explicit links between structured and unstructured data, and that really empowers you to then do better the RAG application downstream. So that's kind of how I see it. Is basically that knowledge graphs are really good at representing or storing both structured and unstructured data, right? Because in RAG applications, most of the time people are just focusing on unstructured data, so like PDFs and documentation, but there's like this whole world of structured data that is kind of ignored or like not really looked into as much as I feel like it should. So I'm here like to advocate for like using more structured information in RAG applications. So now let's bring it all together. Like we want to use AI agents with knowledge graphs, and how can we do that, right? The idea is to give the LLM tools that it can interact with the knowledge graph, so it can either retrieve information from the knowledge graph, or it can also store the information to the knowledge graph. Like it's sort of like a memory of the conversation or interesting facts about the user. And I mean, you can do a lot of things. And at first, when GPT-4 came out, we were all very excited about generating database queries, like either text to SQL or text to Cipher in Neo4j space. So like the idea is you give the LLM user input, database schema, and then the LLM generates a database query that fetches relevant information from the database, right? And this approach is like very flexible. You don't really need a lot of upfront work because it's very flexible, so it's kind of also domain agnostic. And like you give the LLM complete autonomy about what it can do, that because if it can generate database queries, basically it can do whatever it wants with the database. So you kind of give the LLM complete autonomy over the database. Now, one problem is that it doesn't work right for the production use case. Like for demos, you'll see it's kind of nice, and for like toy examples, toy questions. But like when you go to production, generating database queries is usually kind of works maybe most of the time, or even not that, right? So for like use cases when you're just like drafting database queries and you have like a subject matter expert then actually validating those database queries, that's a totally fine approach. But in a RAG pipeline where you have like non-technical users who don't really know what's going on under the hood, like generating database queries isn't good enough at the moment, at least, because it can struggle with complex schemas or questions. And like there's like the whole thing of like mapping because users usually don't use the same vocabulary as the database people, right? So then how do you map these two vocabularies? So there's like a bunch of problems that needs to be solved. And like you can get like kind of good results, and then when you say like when you get like 60-70% accuracy, that's kind of good. But like in a RAG pipeline, do you really want to give that like to your boss and say you ask the same question 3 times and you get like 2 or 3 different results? And then probably I mean, it's a dubious idea, right? So like what's the solution, right? If we can't really give the LLM complete autonomy over the database, I'll do questions at the end. So if you can't really do like direct database query generation, what do you want to do, right? And like before, I mentioned that you can give the LLMs tools to interact with the external world. And in this case, you can give LLMs tools to interact with your knowledge graph, right? And the idea is to move the complexity away from LLMs and switch it or like put it into the tools, right? So you can have like subject matter experts who define those tools, and because they are like deterministic, you know that like if you get the same input, you'll get the same output every time, right? And you can also define what types of outputs you want, so that can also help you design better applications downstream, like chat interfaces, right? And because I said you want to have like predefined tools, so how I see it, basically, mostly there are like two types of tools to interact basically with any database. It doesn't have to be just graph database, but like the first one I call it like Cipher or query templates, where basically you define like your database query. So here in this example, we match an organization by its ID, and then we return its partnership, subsidiaries, suppliers, because we use the same diffbot graph. And in this case, right, you just say to the LLM, if you want to find information about the company, like you give the description of the attribute, and then we do a little bit of mapping to the database. But essentially, the LLM decides if you want to find information about a specific company, and then it just passes that company as the parameter to the template, and then we get the exact same information every time when we're interested about the company. And then the second approach is a little bit more involved. So you can also then dynamically generate Cipher or query statements. So it's not just you have like one static database query where you populate parameters, but like based on the tool input, you can like dynamically generate Cipher statements, and it's like dynamically generated, but it's deterministically, right? So you know exactly for the same input, you always get the same results, right? So again, here you can see that basically the LLM are just tasked to populate the tool parameters, and then the actual retrieval logic it happens inside the code, right? And because it's code, it should be consistent every time, right? So that's kind of the idea, how you can go about moving the complexity away from LLMs to generate database queries and put the complexity inside the code, so you get much better results. And like one example could be like a movie agent. So you can have like knowledge graphs about movies, and then you could give the LLM tools to find, like, let's say, information about movies or people, or like another tool could be to recommend movies. And then finally, because we can also store the information to the knowledge graph, it could be that it could act like as a memory tool. So like if a user says, I already watched Top Gun, you can store that information inside the knowledge graph, and then you can use that information to produce better recommendations next time, right? And as always with knowledge graphs, basically it's domain agnostic. So before we had like a movie agent, and now we have like a biomedical agent, so like the approach is very domain agnostic, but it's very nice, I feel like, because you can combine structured information that you have also with unstructured information. So now let's do like a quick demo. Just a second. So again, we'll be using diffbot as the data provider, but now we'll have like 100 million nodes in the graph, and Neo4j is where we host that information, and then like the llama index will be used like as a simple agent interface. And here's the database schema. So basically, again, we have the organizations and people and news, but it's slightly more involved than in the Lien's example. So let me do the demo now. Let's just see if it works. Okay. So basically, we defined a little bit of utility functions because when you're dealing with structured information, most of the time you need to map values from the user input to the database, right? Because let's say if you want to ask questions about Neo4j, you need to find like the node that represents Neo4j in the database. Right? So there are more, different types of approaches, like you could use vector search, keyword search, combine the two. Here we just use a simple keyword search. And then, as I showed before, we'll have one tool like a cipher template that will be used to find information about organizations, which is this one. And then the second one will be to get the latest news about companies or their related entities. So it should be quite simple. And then we use OpenAI, put it all together with Llama index, and let's see what happens. So now if we ask who are the board members of Neo4j, the LLM decides, okay, I want to call the get company information tool that's available to me. I will populate the parameters, just company Neo4j. This is what it gets from the database, so it's not really nicely printed. And then the information contains which are the board members, and it can generate the final answer to the user, right? So this was the first tool, and then the second tool was to get the latest news. So again, you can use like, what's the latest news about Neo4j? It gets that information, and then generates the answer. So there's like a Neo4j connection event going on. But as I mentioned, because we have information about Neo4j, but also its suppliers, competitors, so we can combine the structured information we have in the graph with unstructured information. So we can say, what's the latest news about Neo4j partners, right? So in this case, we will identify Neo4j in the database, we'll traverse the partnership relationships, and then find the latest news about those entities that are basically partnered with Neo4j. So in this case, we are combining the structured part of the knowledge graph with unstructured part, which are the articles, right? And Neo4j is partnered with Microsoft, and as we can see, Snowflakes, and they're doing a bunch of cool stuff. So, and this is like, I'm sorry, because it has such a nice demo from Lien before, so it might be a little bit underwhelming, but that's the demo I have. And now basically we can finish up. So basically at the moment, like when you're doing agents, you don't want like full autonomous agents to let them just do whatever they want to do, but you want to constrain them with like tools that were defined by subject matter experts. And then how I see it, like anytime you can switch the complexity away from LLMs and change it into code, you definitely want to do that, right? Because with LLMs, most of the time you get like 60 to 80, maybe 90% accuracy. But like if you can change that 60% accuracy to 100% accuracy with the code, you definitely want to do that. So that's it for me, and now I can take some questions.
Raise your hand, I'll bring the mic to you.
Hi, I just want to go back to your slide of the inaccuracy of LLM.
This one?
Could you please explain the x-axis?
Okay, so the most important metric here is pass at 1. So basically, how you kind of usually evaluate database query generation is you don't actually evaluate the generated query, but you evaluate the database, the data that you get from the database. So if the data that you get from the database matches what it should be getting, then we get like 1, and if it's not, it's a 0, right? So the pass at 1 means that 50% of the time we got exactly what we wanted, and the other 50% we didn't get. And then pass at 3 means that, we ran the same query, we generated the query 3 times, and now because LLMs are non-deterministic, maybe one of those 3 times it gets it correct. So like pass at 3 means that out of 3 retries was at least 1 successful. So like we get from 50 to 60, right? And then the jacket means that even though the data wasn't exactly identical, it is still similar, right? I mean, the thing is with database queries, if you run or like LLMs, is that if you run the same evaluation multiple times, you'll get different results. But it's like usually in the 50 to 65, 70% accuracy, right? And as I said, it's good enough for like drafting database queries, but not for RAG applications.
Thank you. So on the slide 18, you mentioned a solution, a predefined toolkit. Subject matter experts can help define how and which information to. Can you a little bit explain exactly, I assume subject matter expert is a human, how this has been done? I mean...
Yeah, so I mean...
Because, sorry,
go ahead.
Before, subject matter expert mean they're very relative, right? Means they subject matter expert within a quote sometime. How the quality of outcome that result out of this sort of approach?
I mean, the quality definitely improves. The thing is that because we have to kind of foresee the use cases and prepare the tools, we definitely limit the scope or flexibility of our agent. But because we limit the scope, we get better results. Right? So you're always kind of trading with like agents. Do you want them to be more flexible and less robust, or less flexible and more robust, right? And I feel like the less flexible, more robust is the way to go at the moment.
What is the right or the upper bound of tools that you recommend using, and is there an approach like re-ranking or something like that for tool usage in order to scale it? Are there any insights about this?
Yeah, I mean, so this is not really yet like a mature space, and it really depends on the LLM that you're using. But like I've seen some studies where they say more than like 15, 20 tools, the accuracy drops significantly. But then it also depends, because with tools, they really should be, how I say, semantically orthogonal, so they shouldn't be very similar, because if an LLM can choose 2 tools for the same use cases, you kind of confuse it, right? And then you can get different results. So you should be careful that you don't really have semantically similar tools. So I would say I wouldn't use more than 10 tools. But as you said, like you can dynamically select tools. So you can have like a vector search and like use the description of the tools and match them with the user input and find the top 5, 10 tools that you want to pass to an LLM. So you can have like a base of 100 tools, but at runtime you just pass the top 5, 10 similar tools to the agent. So in that way you can scale.
I have a follow-up question on that. So is this toolkit entails, like if we are implementing within one enterprise and ecosystem, does this toolkit entails a domain-specific different tools? like in an enterprise is HR, marketing, or different like use cases. So every tool will have a specific domain specific use cases, and will it be AI enabled, models based, or it's an independently driven? Like how does that work?
I mean, so because the tools, like you have the code, right? You can do whatever you want. You can have like nested LLM agents. So like the tool can have additional LLM tools if you want. So the tools can be as complex as possible as you want them to be. But like I advocate that basically you don't want to use too much. Like if you then use again LLM in the tool, right? Then you can again come up with errors of the LLM, right? Because here we show that you don't want to use LLMs when it's possible, right? But you can if you want. But then again, you'll get the non-determinism of LLMs, and then maybe the error rate is greater, right? But for me, I would say like you definitely want to have like very domain-specific tools. So they're not. I mean, as I said, you reduce the flexibility because it's very domain-specific, but you get accuracy, which is nice.
My question revolves around the popularity of Neo4j within the last 2 years. Ever since the democratization of OpenAI, I feel like everyone is starting to move towards knowledge graphs. So my question to you is, what's the next, I'd say, not revolutionary, but the next big thing with Neo4j when it comes to adding new features and new things that you're working on? I don't know if you could disclose that, but it would just be interesting to hear.
Yeah, I mean, I can tell you what I'm working on. So basically, as I said, you can have subject matter experts defining the tools, but I seen that like there's like a bit of overlap in the types of tools that you want to have, right? Because like how I see it at the moment, like you can like do some aggregations, or you want to count things in the database, or you want to list some information. And I feel like that can be very generalized. So instead of having subject matter expert define the tools, we can have like some generic framework that provides the tools for you. Obviously, it's not exactly what a subject matter would do, but like just to get started, I think it should be good enough. So my job, like my hope is to get like, because knowledge graphs can be scary, right? Because you need data modeling, you need like subject matter expert, and like how can you do it like as with vector database? You just click 2 buttons, you do 2 lines and everything. I mean, at least the first steps it works, right? So how can we make like generic tools to pass to an LLM that just work out of the box?
Do you guys have any questions back here? Okay.
Hi. What is this cipher about, and is it a programming language
So this is like
Python, and why your preference?
That's like a sequel for the graph databases.
Okay.
So that.
Okay, I am here for the first time. Okay.
And, I think Michael, you had a comment. No.
He can tell you.
Exactly. I just wanted to say some of the things that are coming for Neo4j for GenAI. So first of all, there's a new Neo4j Python GraphRag package, which can do knowledge graph construction and GraphRag retrievers as well. We will add knowledge graph construction also to the data importer of Neo4j, so that you can basically pass in, folders of files on S3 or Google Cloud buckets, and it will automatically construct knowledge graphs. We just released a relational database import, starting with Postgres, but we're adding many more sources as well. There is copilots now in Neo4j. We just published fine-tuned text-to-cipher models and datasets as well, which also integrate some of the datasets from Tomaž. And we're working on integration with Neo4j with Snowflake, so that you can do graph compute on your Snowflake data as well. So that is also now available in early access. And what we want to do next year is to look into, can we actually integrate agentic tool definitions into the Neo4j Aura platform, so that you can basically then have an UI and APIs that then would use these tools automatically for natural language access, so that you can basically just, by using the APIs, everyone could use the tools that you defined for your databases and for your schemas as well. And the last thing that we've also been looking into is actually use LLMs to support generating graph models, because sometimes you have either unstructured or structured sources that actually have only entity or table information but no relationship information, and then LLM is actually quite useful. There's a whole area of foreign key detection with LLMs, so to actually generate graph models from isolated entity sources as well. So that's some of the things that we are working on or have already released. Cool.
Thank you, Michael. Okay, question.
Have you seen any, it seems as though agents have a far easier time with a simple database schema. Have you seen any movement to have people convert an unusually complicated database into something simpler so that it can be queried? I've encountered this recently myself.
I mean, I didn't see simplifying schema, but I've seen simplifying queries, right? So you can take a user question and then you can break it down. Is this a simple question? It is like a multi-hop question where you're actually answering more questions than just one. So you can do the breakdown, and then you can answer each of those questions separately, or you can have a flow where you generate the ciphers for each of those questions, and then you ask the LLM to combine ciphers together. So it's not simplifying schema. I've not seen that so much, but I've seen breaking down questions into chaining different steps and simplifying the database query generation. I've seen that a lot.
Right, maybe one more question. And then we'll have a third talk, so you might probably want to.
I'm curious if you have tried to get the AI to write the tools for you, as one question, and then as a second question, it seemed like the graph you showed with the bars, that was to see if it could generate consistent, but I'm curious if you feed the errors back to the LLMs and give it multiple passes at generating the query, whether you've tried that and whether that works.
So let's start with the second one. So one problem with doing multiple passes is that you don't really know if the information is correct or not, right? You just know if the query returns some information or not. And you can say, okay, if there's no information, let me retry. But if it's invalid information, you don't really know, right? So in that case, that makes it tough. So you can do multiple passes, but only if no information was returned, because you have no way of knowing if it's valid or invalid. If you knew that, you wouldn't need to do multiple passes, right? So that's it. And what was the first question?
Whether you can use the large language models to write the
Yeah. So that's basically, you can definitely do that. So basically, you just get them to write Python code in this example. It's definitely possible. And it then depends how much human feedback do you want. Do you want to provide the types of questions you want to be answered, and then the LLM generates the tool, or it can be more generic, because what I'm doing at the moment is going more generic route and having a rule-based tool generation, and then the LLM can just define the descriptions, right? So it's the LLM does the prompt engineering, but the actual code is predetermined. So you can do that, or you can have the LLM generate tools as well, but it's not, we haven't tried that out yet.
Thank you very much, Tomaž. Really appreciate it. So,